Next one is equalizers. Equalizers. See, this is an electronic circuit which exhibits a non-uniform attenuation and phase delay with variation in frequency. Electronic circuit which exhibits non-uniform attenuation and phase delay with variation in frequency. See here, what this statement says that let us take AM modulation is there. In AM modulation carrier frequency, something let assume this signal frequency is 3.5 to 300 to 3.5 kilohertz. 300 to 3.5 kilohertz. This entire range of frequency, the entire range of frequencies here, non-uniform attenuation and phase delay. If it is phase delay is there, phase delay means what is? See, let us take this is a transmitter. Here is a receiver is there. I'll take this receiver. So therefore, the water transmitter transmit the signal into air, and this transmitter has to travel receiving antenna in a different directions. Why? Because the electromagnetic signal is divergent in nature, not is convergent. So therefore, some signal will get travel like this and reflected by the atmosphere, and then it reaches here. And some signal will travel like this and this. See here, at a receiver side, the receiver, the total signal received by this receiving antenna is vector sum of this signal 1, vector sum of this signal 2, vector sum of this signal. So if it is vectors, if the distance traveled by the wave is very large, so therefore it reaches late by S2 as compared with the S2 wave. And this S3 will reach to the receiving antenna just before this S1 reaches here. So therefore, S1, S2, S3 signals will reach at different instants of time because of time delay. Because of time delay, phase difference will result. If it is phase difference, then vector sum will become different. Vector sum will become different for different waves. So therefore, we'll get a distortion here. This is undesirable. Distortion should not be there in any electronic circuit. More specifically in a communication signal. In a signal, if it is a transmitting antenna, this is a receiving antenna. In between this signal, so there is a possibility of attenuation distortion. There is a possibility of phase distortion, and these distortions should not be present. Therefore, the equalizers will be used. Therefore, equalizers are a circuit designed to use to obtain overall uniform response. So entire frequency range, we are getting a uniform response of the total working frequency. Of total working frequency, if it is AM, 300 to 3.5 kilohertz frequency, will get a uniform characteristics over this kind of this range of frequencies. So definition means equalizer is a network that is added to the main network to achieve the overall uniform response. Overall uniform response. Next, we'll derive the formula for. So there are two different types of equalizers will be there. One is attenuation equalizer or amplitude equalizers. Another one is phase equalizer and delay equalizer. Phase equalizers or delay equalizers. So for in this case, Here S1, S2, S3 will reach different time instants to the at the receiver and receiving antenna. So there is path difference. Path difference is equal to 2 pi by lambda into phase difference. Sorry, this is a phase difference. Phase difference is equal to 2 pi by lambda into path difference. So there is a path difference, means signal 1, signal 2, signal 3 will traverse a different paths. So therefore there should be some path difference. And this path difference multiplied by 2 pi by lambda gives the phase change, phase of different change. If phase changes, then vector sum is also changes. We'll get some phase distortion here, phase distortion. To avoid this, to provide a uniform phase over entire working range of frequency, we have to use equalizer. Equalizer. So there are two different types of equalizer: amplitude equalizers or attenuation equalizers, phase equalizer or delay equalizer. Next, another based on connections, there is series equalizers will be there. Series series equalizer and shunt equalizers. In series equalizer, say this is a source. Next, this is a 2x. This is the equalizer term. Equalizer is the equalizer 2x1, and this connected to the terminated with a load resistance or R naught. And this is input impedance is also R naught, and this one is Vs, source voltage, and this is a current I. So therefore, whenever an equalizer to be designed, the loss in dB and impedance R naught at which it has to work are given. Here M is the ratio of input power to output power, and whereas the D distortion attenuation D in dB is 10 log 10. Already we studied this, 10 log 10 P input power divided by P output power, and this is in terms of dB. So therefore, P1 P input power to P output power is anti-log D by 10. Simply, this is simply with anti-log. This is a log. If it comes here, D by 10. This is log 10. Therefore, Pn by Pn is equal to 10 power. Anti-log means this is 10 power D by 10, like this, which is equal to M. Therefore, from this circuit, the maximum power output P maximum results when X1 is equal to 0. From see, as we know that this is let us assume this is a circuit. When the maximum power is delivered to the load, so maximum power delivered to the load only when this load impedance is equal to the source impedance. So therefore, this 2x1 should be equal to 0, right? So that which is equal to x1 is equal to 0. So therefore, P in is equal to P max or power max is equal to Vs square by 2 R naught. Why? Because here R naught is there, in this here R naught. If x1 is equal to 0, we'll get a maximum power delivered to the load. So that is, so current square multiplied by resistance. It is a load resistance R naught. So this is simply I square into R naught, where I is equal to source voltage square divided by 2 R naught. Why? Because this R naught and this R naught is in series. When x1 is equal to 0, maximum power is delivered to the load. So therefore, this is Vs square divided by 2. This is the maximum power. So Vs square, this is a whole square, right? Whole square. So therefore, this is 4 Vs square by 4 R naught square, 4 R naught square multiplied by R naught, and R naught, and this is square of R naught is get cancelled. This is Vs square divided by 4 R naught. This is P max. Next, P input over therefore P output. P out is equal to magnitude of current square multiplied by load resistance or not. This is Vs square divided by Z multiplied by or not. So what is Z? So therefore P out is equal to what is that Vs square divided by uh, Z square. What is Z is equal to magnitude of Z square means this becomes root of 2 R naught square whole square plus 2x1 whole square, and this is square multiplied by or not. See here, this magnitude is there, na? Magnitude, this value is a magnitude, root of 2 R naught square plus 2x1 square whole square is the R naught, and this Vs square Z square is there, na? Vs square Z square, so that is this square. So Vs square and Z square. Inside this value is magnitude of Z. So magnitude of Z is this one. So magnitude of Z square means this is square. Now square and this root get cancelled. So therefore P out is equal to Vs square into R naught divided by 4 R naught square plus 4x1 square. But next, what is that? Next, we have to calculate ratio of input power to output power. So therefore, M is equal to P input power divided by P output power. So P input power is Vs square by 4 R naught whole divided by P out. This is Vs square into R naught divided by 4 R naught square is 4x1 square. Vs and this Vs get cancelled. This becomes 4 R naught square plus 4x1 square divided by 4 R naught square. So therefore, this becomes 1 plus 4. This is 4 R naught square divided by 4 R naught square plus 4 x1 square divided by 4 R naught square, which is equal to these 2 are get cancelled. Therefore, 1 plus 4 get cancelled. X1 by R naught whole square. So this is M. So X can be calculated. X1 can be calculated. If R naught and M value is given. So finding of X1 with the values of R naught and M is the design of series equalizer. Therefore, here series equalizer is electronic circuit which exhibits a non-uniform attenuation or phase delay with a variation in frequency. So equalizer network that is added to the main network to achieve overall uniform response of entire working frequency range. And it is very important. Why? Because a distorted signal, because due to distorted signal there is a possibility of some loss. So to avoid this loss, we have to place equalizers. Equalizers provides a uniform distribution, uniform uh, uniform uniform response over entire frequency range. So therefore, equalizers are very essential for a communication circuit. Therefore, we can avoid attenuation, distortion, phase distortion, and all. So here, first we assumed M. So M maximum power is delivered to the load only when load power is equal to the source. So therefore, X1 should be 0. That is equal to P in. If X1 is placed, then what is the output impedance? So output impedance is equal to, again, same I naught I current through this load, current to in uh, so here current through this I output power. P output power is equal to I square, magnitude of I square into R naught. But what is I? I is equal to Vs square divided by R naught plus 2x1 plus R naught. So therefore, this is 2 R naught plus Vs square is equal to 2 R naught plus 2x1. So magnitude of this we calculated here. This magnitude of this quantity. So therefore, finally we got P out this. We calculated P in, we calculated P out, and then substitution. M is equal to input power to the output power. So where we got M is equal to 1 plus x1 by R naught whole square. And this x1 is a equalizer, series equalizer. This can be calculated by knowing value of R naught and M. M in terms of dB and R naught in terms of impedances, which we terminated to the electronic circuits or any electrical circuits. This is all about series equalizer. Thank you so much and all the best for your just study shunt equalizer advantages. Don't need any derivation there and applications. So all the very best for your examinations. If you have any doubts regarding fourth and sixth, fifth and sixth chapters of network analysis, and also remaining previous 4 chapters. So I am going to be uh, available by 24/7 up to your examinations. Whatever the doubt you are going to get while studying while preparing for any exams, and I'll be there for to solve, and I'll clear all your doubts as possible as much. So therefore, thank you so much once again. All the best for your examinations.